So today we're going to look at the laws of logarithms. So yesterday we looked at some of the properties of logarithms, so what they, some of the features. Now we're going to look at the laws of logarithms. So these are some of the rules that we have in place when using and solving logarithms. And where do they come from? Well, if you remember back in grade 9, we did laws of exponents. Things like when you multiply powers of the same base, you keep the base and add the exponents. That's an exponent law. So we have, because logs are exponents, they have similar rules and laws for logarithms. So you see here it says the laws give rise to corresponding laws of logarithms. So today we're going to do very mathematical proofs. But I'll match each mathematical proof with a real number proof. Seeing as we're in a high-level math course now, we're going to start looking at both. Okay, both pure mathematical proofs, but also number ones to make sense. So don't freak out if we see, these letters and all that sort of stuff. We'll be able to see a numeric one as well. So here's what we're going to build all of our proofs and where these laws come from based on these letter correspondence here. So I'm going to pretend we have two separate logarithms. The first one is the log m base a, and it has an exponent of b. And the second one is the log of a different number, or a different answer, same base, but we get obviously a different exponent. So what we're saying is both of these logarithms have the same base, except the first one is being raised to a b, and it gets you the answer of m, and the second one is raised to a different exponent, c, and it gets you an answer of n. The reason we're exploring the same base is because, just like the exponent laws, those ones need the same base, right? So when we're multiplying powers with the same base, we keep the base and add the exponents. So now we're looking at exponents with this, logarithms with the same base. So what we're looking at here, oops. We're looking at what happens when you combine logarithms, okay? So notice I'm now taking the logarithm of a product. So the product is m times n. So this m I'm going to replace with this fact. So this is log base a. M is the answer, of a to the power of b. And n is this answer. N is the answer when we do a to the power of c. So I took this product mn and I just replaced it with the exponents, or the powers. Now look what we have inside the brackets. Here we have two exponents. A to the power of b times a to the power of c. What happens when we multiply powers with the same base? What do we do with the exponents? We add them, that's right. Oops. Now, let's use one of the properties from the other day. I'm asking, what exponent do I put on a to get this power? So this is one of the obvious, or the duh properties from yesterday. What exponent do I put on a to get this? What's the answer? Yeah, it's b plus c, right? So this is like one of those canceling out properties from yesterday, right? So if I'm asking log A base A, well, obviously it's asking what exponent do I put on A to get this? Well, it's right there. It's that exponent. So this logarithm evaluates to B plus C. And now, you look here, there's B, there's C. I can replace B with this whole thing and C with this whole thing. So I'm going to do that here. B is the same as log M base A. And C is log N base A. And this is the law that I wanted you to discover. So it turns out when you're taking the log of a product, you can split them up into a log of the first number plus the log of a second number, which is kind of related to the exponent laws, right? The exponent laws that says when you multiply them, you add the exponents. Well, since logs are exponents, look what I'm doing. I'm adding the logs. Okay? So this is the first one. It's called the product law. And it says log of mn base A, you can split it up into a log of m to the A, or base A, plus log n base A. So I know this is pretty mathematical, but let's look at this with some actual numbers to see where it relates. So I'm going to look at a really simple case. Here's the log of a product, 3 times 7, base 2. So if I just wanted to apply the law, I just wanted to use the law. It's not going to really help us that much, but I just want to use the law that says, okay, I'm taking the log of a product. I can split it up into 2 separate logs and add them. So this one would be log 3 base 2 plus log 7 base 2. All right, that's just using the law. That's it. Okay. It really doesn't help us much more in this question. It will later on. So for example, it'll help us in something like this, where we would go the other way. So here's an example, log 128 base 4 plus log 2 base 4. Well, you can fiddle around on your calculator here and realize this number here is not an easy number to find. What exponent do I put on 4 to get 128? So if you start fiddling, you don't get something really easy. You know, I don't know what it is.
Mrs. Johnson, contact the office, please.
This one, especially here, is really hard to find. What exponent do I put on 4 to get a 2? Well, that seems weird, like you get a smaller one. Okay, now you might be able to figure them out, but watch what happens when we use the law. So this is in the opposite direction. Here I have 2 logarithms. They happen to have the same base, and they're being added together. So since I have 2 logarithms with the same base that are being added together, I can combine them into a single logarithm and multiply the answers. So going backwards then, this is log with the base 2, or base 4, excuse me. And I can multiply the answers. So 128 times 2. So that's log 4, and that's what, 256? That number is a lot easier to figure out. So this asks, what exponent do I put on a 4 to get 256? So can someone help me out? 256 to the power of 3. Okay, 3's not big enough. 5's too big. So it's 4. So there, we just go off and say the answer is 4. By applying the product law, and we've made the question a little bit more easy. Okay? And this is going to happen in more detail in other questions later on, where you look at the two logarithms, it doesn't make sense, but if you combine them into a single logarithm, it's easier. Or vice versa, you might have one single log that's hard to find, but if we can split it up into an addition, then each of them will be easier.